Okay, so we're going to talk about how to classify triangles. So there are two different types of ways you guys can classify triangles by their sides. So we have some names for the sides of triangles. Then we have the classification in terms of angles. So when you're talking about just the sides only, you don't know the angles, you only know stuff about the sides. Hopefully you guys remember equilateral means all the sides are congruent. Isosceles means that at least two are congruent, and scalene means that none of them are congruent. That's familiar, right? Do you guys remember all those? A couple of extra things to remember about isosceles. Not only do the sides have special names and special relationships, we also work with the angles a little bit. So these two sides that are congruent, we call those the legs. So if you're looking at a triangle and you see that two of these sides are congruent, we call those the congruent sides or the two congruent legs. And then the other side that's not congruent to the other two is called the base. Now this is very important because we're going to learn a theorem down here. It's kind of cut off on the screen, but on the next little section of your notes, we're going to talk about something called the base angles theorem. So that's why this vocabulary word is very important. So the side that's not congruent to the other two is called the base, and the angles that are along the base are called base angles. Kind of goes along with that vocabulary. The two sides that meet that are congruent, the point that they make when they're congruent is called the vertex angle. So these vocabulary words are very important, specifically for the isosceles triangle. I may say, can you find the measure of the base angles for me in a question, and you need to know what that means. So make sure you guys are good with that vocabulary. All right, you guys have probably never heard of this one, or who has heard of equiangular? Have you guys ever heard of that one? You have equilateral for the sides, you have equiangular for the angles. So if all the angles are the same, you call that equiangular, right? I want you guys to put a star next to this one, because this is actually a very important rule. If all of the angles are congruent, but they all have to add up to 180, what does that mean the measure of each of the angles would be? If you know that they're all equal, but they should all add up to 180, they all have to be 60. So this is something that you guys need to know, and a lot of the times that's going to be one of the strategies you need to do to solve any question. So if you don't remember that all of the angles are the same, and that means that they're all 60, you're probably going to be stuck. There are questions that really require you understanding that. So put a little star and remind yourself that when all of the angles or all of the sides are the same, these are really the same kind of triangle. If all the sides are the same, all the angles are the same as well, they're all going to have a measure of 60. So that's an important strategy to remember. Then we have our acute, obtuse, and right triangles. I'm sure you guys have heard of those. Something that's very important for acute triangle is this word all. So you want to underline that. For it to be an acute triangle, every single one of those angles, all three of them, have to be acute. So take a look at this picture. If I were to show this to you and ask you what kind of triangle it is, can you say that it's acute just based on the fact that you have a 70 and a 40? No, what would you have to do first before you can decide? You have to find out what the other angle is by subtracting these two from 180. So what would that give me? If I take these two angles and I subtract them from 180 to find this one, what would I have?
87. No. 7.
It would be 70. Right? So now that I have all three angles, are those all acute? Okay, so then I can say it's an acute triangle. So never make any assumptions. Always make sure you know exactly what each one of those angles are and measure before you decide whether it's acute or not. Obtuse angle, another important word to underline is 1. You can only ever have one obtuse angle in a triangle, otherwise they would add up to more than 180, which is not allowed. So if you see one obtuse angle, you can automatically figure out the other two are going to be acute, and that would label this as obtuse. And then obviously you guys know your right triangles, right? Do you guys remember what a hypotenuse is? You heard of that? Okay. Hypotenuse is the longest side in a right triangle, and it's across from the 90-degree angle. We're going to be talking about right triangles specifically in Unit 7. Alright, so there's a little vocabulary. Some of it you guys may have known, some of you may not have known some of that, but hopefully you'll be able to access that easily moving forward. Does anybody have any questions about that vocab stuff? Okay. We have 3 theorems that we're going to talk about. We use these to help us solve. Hopefully you guys know this one. You guys have heard that before, right? We've actually been using that already. What do all the angles inside of a triangle add up to?
180.
180. That's called the triangle sum theorem. It actually has a name. So the triangle sum theorem tells you that all 3 angles add up to 180. You guys may not have heard about this one though. It's called the exterior angle theorem. Right? The exterior angle theorem says that if you take the side of a triangle, like the side right here, I took the bottom side of the triangle and I extended it. I drew it a little bit longer so it went out past the triangle. This angle right here is called an exterior angle. So if you extend the side of a triangle, and then you have this angle right here, this is equal to the two inside angles added together. Again, the exterior angle theorem says that if you create an exterior angle on the outside, it's going to be equal to the sum of the two interior angles that are on the other side of the triangle. You're not going to use this angle, the one that's adjacent to it, you don't use that one. Okay? You have to go all the way to the other side of the triangle and add those two together. Okay? So for instance, if I said that this was a 120 degree angle and this was a 10 degree angle, how big would angle 1 be? It would be 130. The exterior angle is equal to the two inside angles across from it added together. That's what remote means. Remote means opposite or across the triangle. So that's a theorem that's going to come in handy a lot. So make sure you remember that one. And then here's our base angles theorem. This works only for isosceles triangles. So if you notice that you have two sides that are congruent, you can conclude that there will be two angles that are congruent. So whenever you see a triangle, you see two congruent sides, you can remember that if you see two congruent sides, you will also have two congruent angles. It also works the other direction. Do you guys remember what a statement is called if you have if and only if? Biconditional. So this means that it works both ways. If you see two congruent sides, you have two congruent angles, or if you see two congruent angles, you have two congruent sides. So that's why I drew this double arrow here. So it goes both ways. If you have the sides, then you have the angles, or if you have the angles, you have the sides, it works both ways. So that's something you guys will be using as well to help you solve. If you see that these two angles are equal, then the two sides are equal. You can just write an equation. So these are three different theorems that we're going to practice with in this little chart right here. Okay. I'm going to go ahead and number these 1, 2, and 3. And as we're working through these questions, we're going to write the theorem that we used. So you can see the different kinds of examples that each theorem would work for. So for this one right here, I'm trying to solve for x. Which theorem, 1, 2, or 3, would be most helpful in this question right here? The first one, theorem 1. What does theorem 1 tell me? All the angles in a triangle add to 180. How can I use that for this question? Well, can I just write like one big equation using that theorem? Yeah. I can take angle 52 degrees plus 43 degrees plus x is equal to 180. I have something written for all three angles, so I add them together and set them equal to 180. And you just do a little bit of algebra, combine those two, and then subtract them to the other side. What would you get? 85? Did everybody else get 85? Okay. As a follow-up question, if I asked you what kind of triangle that was, what kind of triangle is this? It's an acute triangle. What else? That's by angles, by sides. Scalene. If all the angles are different, that means all the sides have to be different. Okay, so this is an acute scalene triangle. All right, which one of the theorems, 1, 2, or 3, would help me for this one? Which one of the theorems, theorem 1, theorem 2, or theorem 3, would help me solve this question? 1? Why? I'm trying to solve for x, but how? Okay, I have three angles all labeled inside the triangle. What do I know about all three angles of a triangle? They add to 180, so that's why theorem number 1 applies here. So I'm just going to combine everything in my head. So x plus 3x plus 2x is 6x, and 40 minus 17 minus 5 is 18. Is that right? 40 minus 17 minus 5. Is that 18? Yeah. So you can feel free to write the entire equation out. It's just a lot of writing, so I went ahead and combined all the like terms in my head. Just add everything together. Now that I have this, I'm going to subtract the 18 over and divide by 6. What did I get? 27? Cool. Alright, is everybody with me so far on why I use theorem number 1 to solve the first two? Typically you use theorem 1 when all three angles have something written, like they all have a label, whether it's a number or a variable. If all three angles are labeled, that's usually when you use theorem number 1. You just add them up to 180. Alright, which theorem would I use to help me with this one? Why? Say
The line extended.
Okay, so I extended one side of the triangle to create what? What would I call this on the outside? An exterior angle. So when you see that, when you see one side of the triangle extended out like this and you have that outside angle, I'm going to be using theorem number 2, your exterior angle theorem, which says what?
The exterior is two interior angles.
Added together?
Yeah.
Right? So the exterior angle, 6x minus 7, should be equal to the two angles across from it on the inside added together. So that would be 103 minus x plus 2x. That's our exterior angle theorem. The outside angle is equal to the two inside ones added together. And we're just going to do a little bit of algebra to solve this. So if I add the x and then subtract the 2x over, that'd be 5x, right? And then add the 7 over. You can do your algebra, shifting stuff around and combining like terms. You should get 5x equals 110. And then divide by 5. And Alright, why couldn't I use theorem number 1? Why couldn't I use the triangle sum theorem? Yeah, I can't use the triangle sum theorem because I don't have this angle. In order to add all of them together and set them equal to 180, I actually have to have something written there, and I didn't. So that's why I couldn't use the first theorem. Alright, what about this one? You're using the second one? Okay. So we have a bunch of extensions for our triangle, so we might be using the exterior angle theorem. I can see that x right here is an exterior angle, right? I extended this side of the triangle to create angle x. But in order to find angle x, what two angles do I need on the inside? This is not inside the triangle. Remember, the exterior angle is equal to the two inside angles that are on the other side of the triangle. So I have one of them, but I don't have this one. You guys see, I need this angle and this angle right here in order to find x. So I have a slight problem. I'm missing one of the angles I need, Henry.
Isn't 140 linear?
It is. 140 is a linear pair with the angle I need. So is that helpful?
It was 180.
Okay, so what's the angle that I need? 40. You may need to use outside information to help fill in the diagram a little bit. So in order to find x using theorem number 2, the exterior angle theorem, I need these two angles to add them together, but I didn't know this. So I had to use the 140 and the linear pair to get the 40 right there. So now that I have both of those angles, x is equal to 40 plus 85 using the exterior angle theorem. And add those together, 125. Is that right? There you go. Some of them are more straightforward, some of them aren't. So you gotta make sure you're paying attention. Alright, which theorem would I use for this one? The third? Okay, remember the third theorem says that if you guys have two congruent sides, then two angles are congruent. Or, if you have two congruent angles, you have two congruent sides. In this picture, I have two congruent angles. So that means somewhere in here I'm going to have two congruent sides. You guys have to be very careful. Which two? Which two are congruent?
1,
You can tell me the label.
Angle.
Which two sides would be congruent?
X minus 520.
Yeah, these two. Right. The way that you tell which two are congruent is you think of, if you think of the little angle as like a cannon, if you shoot like a cannonball, whatever side you would hit with from the angle, those are the two that are congruent. That's the idea of opposite. So it's the two sides that are opposite the angles that are congruent. So you draw a little crisscross like this. Those two are going to be congruent. So you can just write an equation. 22 is equal to 3x minus 5. They're equal to each other because the angles are equal. And then you add the 5 and divide by 3. What do you get? Right, so again, to figure out which of, because there are three sides, to figure out which two are congruent, you think about going across from the angles, and whatever two sides are across from the angles, those are the ones that are. Right, which theorem helps me across the way, the very end of the row. Okay, the third theorem. Again, the third theorem says that if you have two congruent sides, you're going to have two congruent angles, right? But am I looking for angles? Are they asking me to find angles? No. So I know that if I have two congruent sides, I will have two congruent angles, but they're not asking me to solve for angles. So how can I, this is deceptively simple. How would I solve this?
15 equals 2x plus 1.
Yeah. This one is related to the theorem 3, but I'm not actually using the theorem because it's not asking for angles. If you see the little hash mark, remember that means that they're congruent. So if they're saying 15, the side of the 15 is equal to the side of the 2x plus 1, you just step me. 3, 4. Then x is equal to 7. Do it need the 20 at all? No. A lot of the times in these pictures, they will give you information you don't even need. So make sure that you're paying attention and only using the information that's relevant. Alright, so everybody okay with those first examples? Okay. What about this guy right here? Which theorem would I use to help out? Anybody want to tell me something they noticed about this triangle?
Two lines are congruent.
Okay, so two sides are congruent.
What was it?
What is it? What can you figure out if the two sides are congruent?
They're saying the same.
Hmm?
The same.
I understand, but we're trying to find angles. Which theorem are we using?
Third.
Third one. The third theorem says that if two sides are the same, then two sides are equal. What else? Two angles are equal. Which two? This one?
Up there, one down there to the right.
This one? Okay, that's correct. Remember, to go find the two angles that are congruent, again, you go across from the two sides that are congruent the same way that we did for the other one. So the angle across from this side is right here, and the angle across from this side is right here. So these are the two base angles that are congruent. How does that help me? How does that help me? I know they're congruent, but how does that help me move forward?
So you know the other side.
What do you mean?
It's going to be 2x plus 3.
Okay. So if we know they're equal, I can write down what is equal to, right? If they're both equal, they should both be 2x plus 3. So I'm going to go ahead and write that into the diagram. Now, using theorem 3 is helpful in figuring out more information, but can actually use that to solve. Like, would I be able to set these two equal to each other and actually get a number? No. Oh, I can also use theorem 1. Sometimes you have to use two theorems together, all right? So use theorem 3 to help me figure out what the third angle was as an expression. Now I'm going to use, theorem 1 to do what? They all add up to 180. Again, you can only use theorem 1 when all three angles have some sort of label inside. So now I can say 2x plus 3 plus 2x plus 3 plus 110 is equal to 180. I'm going to go ahead and combine like terms in my head. So 4x plus 6 plus 110. I combine the two expressions together. And then we solve that for x. It brings 116, 180 minus 116. The final answer is what? 16. The final answer is 16? Okay. So hopefully when you finish all of your math, is that right? I haven't looked at things in a while. Yeah, 16. Alright. So again, you can use multiple of these or multiple theorems to work together to solve your question. Alright, which theorem would apply for this one? 1, 2, or 3?
3.
3? Why? No.
Only one.
How would it be 1?
Well,
How would you use angle 1 to solve?
Two sides are congruent.
You would do 5x plus 6 equals 10.
Yeah, I have 2 congruent angles, which means that I have 2 congruent sides. Which 2?
5x plus 6 equals
1,
10.
yeah.
both sides.
These 2.
Oh my
Alright, you completely ignore this guy. Not helpful. You can cross it out, scribble it out, whatever, just ignore it. So the 2 sides that are across from the angles, those are the ones that are congruent. So I'm going to write an equation. 5x plus 6 is equal to 21. Like this. Then you subtract the 6 and divide by 5. 3. X equals 3. Now, I was kind of alarmed at Jonathan's suggestion using theorem 1. There's always at least one student who does this. They look at the sides and think that the sides of a triangle add up to 180. Is that what the theorem says? No, it says all 3 angles add to 180. So if I see any of you guys see something like this and you try to add the sides to 180, I'm going to be very disappointed.
I was just trying to, I didn't see it. I was just trying to say what it was. Okay.
But you didn't have that.
Alright. You don't have any of the angles actually. Alright, this last one right here. What would I do? What's going on?
Third one.
Third one.
The third one, why?
Because
Because you bring up two angles are equal.
Okay, so they gave me numbers instead of the little markings, but you can add them in if you want to. So those 2 angles are congruent, so what does that mean?
4x minus 3x plus 12.
Yeah. If the 2 angles are congruent, that means the 2 sides across from the angles are also congruent. So I can set up an equation. 4x minus 3 is equal to x plus 12. Oops. Oops again. Stop it. Okay. What would you get for the value of x? 3? 15? Yeah. Nope. 5.
It's 5.
Oh my god.
Oh my God.
I heard someone say 3 and I was like, cool. No, it's 5.
I was on 3.
Because 15 is 15.
Oh, you minus 6.
Yeah.
And
Alright, is everybody clear on how to use those theorems? Is everybody clear? Yes? Then I'm gonna let you try those on your own. They're a little bit more tricky.
what?
I'm gonna let you guys see if you can figure out those on your own. We're solving for x and y for this one, just x in that one, and then x, y, and z in that one. I'll give you guys a few minutes to try that out on your own.
Oh.
No, we're just nowhere.
So I combine my terms. So for this one, I added this plus this plus this.
Something.
Instead of writing out yourself, and I added these two together. I was just doing it like once.
So they're all axis? Or what's
And
X?
just adding the two X and the two X together. And then saving three and then add it. Alright, you guys should all be working on these three and then top of the next page. Yeah. Yeah. Oh, I did it wrong. Well, this one's X and Y. The next one over is just X, and then the third one is X, Y, and Z.
Oh, okay. Where's the mark? Where's the mark on this?
There is a mark everywhere. She literally told you. Yeah, that's what I'm saying.
You drew that with a pen.
I did. Now I did this.
But they crossed out.
Right out, right? Huh?
What?
For a second.
What about it?
It's going to be negative 3x equals 2x plus 7.
No.
See? What was that?
What did you do? Work for that one. What did you do?
Oh, no, I don't understand. Like, with all the work is right.
Yeah, so it
Yeah.
is.
I don't know what you do.
The old has to.
Angle?
No, the sides.
Does it matter?
Sam won.
It doesn't matter. It's because they're all congruent.
That's what happened. You can last you 2 years.
Okay. Here you're working.
No, I never did.
Yes, you do.
I have 6.
Dan, come here.
6 numbers. I mean, hard.
There are no lines.
Oh, that's not.
Because like,
They're probably, so we're not using these two. If you want to use it here in the room. Well, what goes here? That's easier. What should I go
Okay, look. So y equals x between 20 and minus 1 and I get to x. Yeah, and then I can use these two x's are so equals. No. Because it's Spanish.
What do you say?
You're Spanish.
Yeah.
Select.
And then x here equals.
You're like,
It's broken.
no, it's not. Imagine. I'm gonna do
Yes, you did. How would
James. What did you say?
Alright, that's what you guys should have gotten. Alright. For this question right here, you guys should have noticed that this triangle on the left is what kind of triangle?
Lateral.
Equilateral, which means what about the angles? They're, yes, they all equal 180, but what about them specifically? They're all equal. Remember, that's why I had you put a little star next to that definition, equiangular. If it's equilateral, it's also equiangular, which means they're all the same. So automatically you can see that x is 60, just by knowing that it's equilateral. Alright, y takes a little bit more strategic thinking, because automatically I have numbers here, right? I can see that because of the definition of the triangle, but I don't have any numbers in the other triangle. So how am I supposed to solve for y?
Yeah, those two triangles, two sides.
Oh, why is the verb where it's like, oh, you can grab. Okay.
There are two different ideas going. What kind of triangle is the one on the right? This one right here. What kind of triangle? It's isosceles. Do you guys see how this is an isosceles triangle? It has two sides that are congruent. What did we learn about when you have two sides that are congruent? Two angles are congruent, but which two in this picture? This one and this one. Remember, it's the two angles that are across from the two sides, right? So those two are equal. What's something I could add into the picture?
Y.
Another y. So there's another y right here, because they're equal, so this was y, so it has to be y. So I filled in the picture a little bit more. Now there are two different ways you guys can approach this question, right? You can notice that this 60 right here is exterior to this triangle. You guys see how the 60 is an extension of the side? You could use 60 as an exterior angle, and you could do 60 equals y plus y using theorem 3. Or, if you don't see that, you can use linear pair. Do you guys see how these two angles right here are a linear pair? You can go ahead and put a 120 right here, because those two add up to 180 because they're a linear pair, and you can add these three together to 180. So you can either use theorem number 1 or theorem number 2. It's really whichever one you guys see first. Right? Most kids see this one first, because you can just shift the information over by using linear pair, and then you can just add them all to 180. Either way, you would get 30. For this one, all three sides are congruent. Please do not try to write an equation saying that negative 3x equals 2x plus 10 equals x plus 8. Right? An equation doesn't use three things, it only uses two. Does it matter which two I set equal to each other? No. You take your favorite two, equal them to each other, solve, you'll get the same answer regardless of which two you use. Okay? Over here, excuse me. Over here, you guys have two options for which variable you want to start with. Could I possibly start by finding x? Can I start by finding y? Could I have started with finding z?
No.
No, there's not enough information to find z, but you guys can choose which variable or x or y you would like to start with. If I started by finding x, which theorem would I have to use?
First.
No. X is an exterior angle to this triangle.
Oh, they're two different.
Yeah, they're two different triangles that are touching. So this x is technically exterior to the one on the left. So you can use the exterior angle theorem that says x is equal to those two angles added together. Or you could find y first. You can find y first by doing the first theorem, right? 44 plus y plus 17 equals 180. You can find y first. And then x and y are a linear pair. So it just depends on which theorem you guys want to do first. And then once you find x, you guys are able to find z by using the triangle sum theorem, by adding them all the way to 180. Right, so there are a couple different strategies you guys can take to solve for these. Particularly if you guys have this linear pair kind of situation going on, you can choose between the exterior angle or the triangle sum. But hopefully you guys are able to figure that out on your own. Right, any questions about those before we move on to a totally unrelated topic? Yes? Everybody good so far? Just before I move on, I want to make sure it's clear to you guys. An exterior angle can be exterior to one triangle, but be inside another one. Right? Just because this x is inside of this triangle doesn't mean that it's not exterior. Right? It's still exterior to this triangle. Just make sure you don't confuse that. Right? It's so easy, it's confusing.
No, like easy, but it's fun. Started.
She's not fun.
Alright. So on a completely unrelated topic, we're switching. Right? So we're switching into talking about congruent triangles. This is what the entire rest of the unit is going to be referring to. Congruency. Right? Congruent is another word for the same or equal. So we're going to be looking at triangles that are equal, but we're going to have to figure out why are they equal, and how can I use that to help me solve or analyze the diagram. So when you guys have congruent triangles, right, they're going to have congruent, please don't mess up the word while I'm writing, congruent corresponding sides and angles. Congruent corresponding sides and angles. Now, unfortunately, in this context, corresponding does not mean quite the same thing as it does with corresponding angles with parallel lines. Corresponding, really, if you look it up in the dictionary, just means matching, right? Kind of following up with something in a different diagram. So when I'm talking about corresponding sides or corresponding angles in triangles, I'm talking about if I choose like angle C. If I'm talking about angle C, what's the matching angle in the other triangle? D, and how do you know that? Because they both have the three little markings there. So that's what I mean by corresponding. You're going to match up the sides that kind of align with each other or equal to each other in each picture. Okay? That's what corresponding means in this situation. Matching. Right? If you want to write that in parentheses or draw a little arrow and write the word matching, that might be helpful. But that's what I'm referring to when I say corresponding in this scenario. Okay? Now we're going to be talking about triangles that are already congruent in this context. In the next 2/3 lessons, we're going to be talking about how to prove if triangles are congruent or not if we don't know in the first place. But in this context, we already know that they are. So we're going to be talking about a congruency statement, right? So a congruency statement expresses that triangles, I'm going to use a symbol, triangles are congruent. Oh. A congruency statement expresses that triangles, I wrote a little triangle symbol, triangles are congruent. Now this is actually really, really important. The most annoying thing for students in this unit is being able to write things appropriately when we're talking about congruency statements. So basically I'm going to say that triangle blank is congruent to triangle other blank. But we have 3 letters. Remember, you name a triangle using the 3 corners. It's very important that the letters that you use match up. They have to match corresponding parts. So in parentheses, after this I want you guys to write this next little statement, which is very important. The name of each triangle must be in the same order. The name of each triangle must be in the same order according to the vertices, and I'll explain that word in a second. Write that in parentheses. The name of each triangle must be in the same order according to the vertices. Oh, I could have made it. Alright, vertices is the plural of vertex. And a vertex of a triangle is where the 2 sides come to create a point. So when we're using the vertices to name, they're going to have letters. So when you're naming the vertices in a particular order, like if you go clockwise or something, you have to make sure you go in the exact same order in the other triangle. If you don't do that, your answers are going to be incorrect. So you have to make sure that you're really paying attention to that in this unit in particular. So let's take a look at these triangles. I have everything marked, right? So which triangle, in this triangle I have angle C. In the other triangle, what would be congruent to angle C? Angle D, we already talked about that one, right? All right, angle T is in this triangle. In this triangle, which would be congruent to that? G. And how'd you know? It only has one little marking, okay? Yeah. You haven't written down anything that I've written so far.
Is that a P? Oh, no, I remember saying.
All right, angle S is right here. In the other triangle, what would be congruent to angle S? Angle L. All right, so in order to figure out which ones are congruent, you just look to see which ones have the same number of markings. Which side would be congruent to CT?
G?
Okay. D, G. Now, I have a question. If I had written it as GD, like if I switched the order of the letters, do you think that would have been acceptable? No. That's another thing that's very, very important in this unit. If I have to do the correct order when I write the full triangle, I also have to do the same thing with the sides. Do you guys see how I started with angle C, which had the 3 markings, and then I went down to the angle that had the 1 marking? You have to mimic that exact same pattern over here, go from 3 to 1. If you go backwards, that would be incorrect. See how the details are so important in this unit. You guys have to be very careful. So TS. TS is going from the single marked angle to the double marked angle.
GL.
So GL. All right. Then SC is going from the double marked angle to the triple marked angle.
LD.
LD. So you have to be paying attention. As you're doing this, you have to pay attention, make sure the letters are in the correct order. Now we're going to name the full triangles. We're going to name the full triangles. Who wants to name? You guys can name the first one however you want. How would you like to name this one? You choose the order at the beginning. Anybody? Say again? Okay. So we're going to start with TSC. You get to name the first triangle however you want. You get to set the stage for the order. It's just the second triangle that you have to be very careful with. We're going to use the congruency symbol, which is an equal sign with a little squiggle over top. And then you guys have to be very careful. Which vertex corresponds with T? G. So that would be the first letter because it has to correspond with T. Which vertex, which point corresponds to S? L. And which vertex corresponds to C? D. So you have to make sure that you're writing those letters in the correct order once you set the stage with the first name. Okay? Let's see. Alright, what about this next one? One has three letters, so you're going to have to be patient with yourselves. So when you have three letters, you have to be very careful. So K to G to H. Right? It went from the double mark to the single mark to the third mark. So H, J, K. You have to mimic the exact same journey that you took in this triangle and the other one. So if I went from the double mark to the single mark to the triple mark, I do the exact same thing in this triangle, which goes from H to J to K. Right. Now this next one, I'm going from G to K to H, which is from single to double to triple. So single, what? J, H, K. Do you understand the difference, Jonathan? Do you see the difference? I went from single to double to triple. So you have to make that exact same pattern. What's that game that you have like the lights that flash and you have to do the same pattern?
Simon.
Yeah, so it's just like that. When you see the pattern, you have to mimic that in the other triangle. All right, KHG is going from double to triple to single. So double to triple to single. So H, K, J. Does everybody understand what I'm doing here as I'm traveling through the triangle? Is everybody picking up on that? Tara? You guys? Alright, so yeah, it's a little bit more tricky when the angles use three letters. Alright, what about GH?
JK.
Okay, G is the single mark, so we're going single to triple. How do I mimic that over here? Whoever said JK was correct. Alright, single to triple. Now in this triangle I'm going single to double, so that would be JH. And now I'm going from K to H, which is double to triple. HK. Right? Everybody good so far? Alright, somebody else who would like to name one of our triangles here. Anybody creative? Have an idea?
J.
I need three letters to name the triangle.
You
You just get to pick the order that they're in.
J.
J-H-K? Okay. Alright, so we've decided to name this triangle first. We called it J-H-K. We have to write the congruency symbol and then name the other triangle in the same order where the corresponding vertices match up. So what vertex matches with J? G. And the other triangle G matches with J. Which vertex matches with H? H is the double. So it would be K over here. And then which vertex matches with this K in this triangle is the triple mark? So it would be H in the other triangle is the triple mark. So you have to make sure you understand which triangle you named first so you can transfer to the other triangle. And again, this will be different for all of you guys. If you choose to name this differently at first, then this answer will be different for you. So this is a very personal, kind of individualized kind of situation. But once you set the stage using this, the rest of your answer needs to be very specific. All right, this next one, instead of giving you a picture, I've reversed it. I reversed the question. I'm giving you the congruency statement, and based on that, I need you to tell me what is congruent. This is actually easier. You can just use the name and work it out. So I have it set up already, so everything's in the correct order. So what corresponds to A? F. They're in matching positions in the name, so A and F have to correspond. That's why it's important to write the congruency statement this way. What corresponds to B? E. What corresponds to C? D. You get it all from the name. You just look to see, oh, A was first, and F is first, so they correspond. It'll always work out that way for the name. All right, A, B. Those are the first two letters. F, E. And again, just keep the same order as you see in the name because it's already set up for you. Right? BC is the last two, so that would be ED. And then CA is the last and then swings back around to the first. DF. So when you guys have the name, it's actually way easier because they already have it set up for you where everything's matching. So you just have to make sure that you write the letters in the correct order. Okay? Everybody good with that? The naming and the details are so important in this unit, so make sure you're really careful with that. All right, last thing here, we're just going to do a little exercise on that and then we'll be done. So here, you guys can use congruency to help you solve. All right? If we know that these shapes are congruent, that means all the different parts are congruent, right? If they're completely equal, they're copies of each other, shouldn't these two sides be equal, those two sides be equal, right? So we're going to use the congruency statement to help us solve for x. Now, the name is very important. When they give you the name, they're giving you the key to unlocking the solution. They're telling you what matches to what. This is particularly important when they give you a triangle that kind of looks like it's been twisted a little. And you can't tell which sides are corresponding. The name will tell you, right? So x is right here. Which angle is that? U. So let's go to the name. Which angle in this triangle corresponds with U? G. That's this one right here. I currently don't know what it is. Currently I don't have a number for that. Okay. So I'm going to have to use this picture to help me find what this angle is so I can set it equal to 2x. Right? So let's just work in this weird trapdoor thing over here. How can I solve for that angle? What's significant about the shape? What do you notice about it?
The 90-degree angle of those things.
Why?
It's parallel.
Okay, so we have parallel lines. Remember, everything from Unit 3 is going to carry through. We're going to be using parallel lines moving forward. So if I have parallel lines, which transversal would I want to use? This top one or this bottom one? Right. So if I draw this picture right here, would I use the 85 to help me solve? No, I would use the 90. So what kind of angles are these two? Consecutive, interior. What do you know about the measures of consecutive interior angles? They add to 180. So if this one's 90, what's this one? 90. So you can add that 90-degree angle because we use the work with the parallel lines. So now I know that this angle is equal to 2x, so I can say 90 is equal to 2x because these two angles are congruent. The shape's being congruent. So when you solve, what's the measure of x? 35. So everybody see how I did that? It would have been a lot easier if I just told you what this angle is, but why? So in these pictures, sometimes you need to use the shape itself to find out what that angle is, and then you can use the corresponding to figure out x. All right, is everybody okay with that? Okay, what about this one? Can you guys tell just by looking at it which sides are corresponding? If I didn't give you the name, would you guys be able to tell for sure which angles match to what, which sides match to what? Probably not very easily. So that's why they give you the name here. So you know what's corresponding to what. So which variable do you guys want to find first? Your choice. A? Okay, so A is right here, this angle right here. That's angle O. Look at the name. What corresponds to angle O? Angle Y, so it's right here. So how could I write an equation to help me solve? 7a minus 4 is equal to 38. Remember, these triangles are completely the same in all respects. So that means that the angles are equal to each other. So I just take the two corresponding angles, and I set them equal to each other. So if I add 4, I get 42. What's 42 divided by 7?
6.
So A is 6. Alright, so to find B, that's this angle, what corresponds to X? X and N, so that's this angle right here. Do I know what N is? Is there anything written there? No. So my first mission is to find it.
You have to plug in 6 to A.
Okay.
7.
7 times 6 is 42 minus 4.
Which that equals 271.
No,
No,
38.
That equals, I erased it.
Right now we're trying to find the measure of n because we don't know it. So we plug a in, which we just found.
Oh, 119.
38, what's 38 plus 74? 112. Yeah, 112.
112.
Oops. We're trying to find, we're going to use the triangle sum theorem. So if these two add to 112, if you subtract that from 180, you're going to get this angle. What is it? 68. Right, so we kind of had to go on a tangent a little bit. We knew that these two are going to be equal to each other, but we didn't know what it was. So we had to go on a tangent to find what the measure of n was. Now you can write the equation 68 is equal to 4b plus 8. And then solve that. You guys should know how to solve that.
Something's going wrong for that solution. I'm just trying to solve it.
What do you guys get? 15? Alright, so just to recap here, sometimes they make it really simple and they give you what you need directly. You have this one and this one, you set them equal to each other and you solve, right? Very straightforward. Sometimes they don't. Sometimes the angle that they want you to use is completely blank. You have to go on a tangent to use the other things we just talked about, the triangle sum theorem, the isosceles angle, base angles theorem, stuff like that, to figure out the angle before you can actually solve. So just be aware of that situation where they may not give you everything you need up front. Right? That's our first lesson. Does anybody have any questions? Okay. You guys can start the homework if you would like. Take a look at it. If you see any tricky ones, we can work on it together.